Well, we have finally arrived at Euclid Book 6, proposition number 33. And boy, I tell you what, this one's a monster. It's the last proof of Euclid Book 6. From this point forward, until we get finished with Book 9, we're just going to draw simple straight lines. None of these complex shapes and all this other stuff. That comes back in Book 10. But we're not going to worry about that in Book 10. For the next 3 books, we don't have to draw anything complex. Just simple stuff. Thank heavens. Okay, let's get into this. In equal circles. Well, this is circle number 1. And this is circle number 2. Angles have the same ratio as the circumferences on which they stand, whether they stand at the centers or at the circumferences. Okay. Let A be C. Well, here is A, B, C. D, E, F. D, E, F. They'll be equal circles. And let angles BGC, BGC, okay, and EHF, EHF, be angles at the centers G and H. Well, here's G, and here's H. And at the angles BAC, BAC, okay, and EDF, EDF, angles at the circumferences. Okay. Now then, he says, I say that as the circumference BC is to the circumference EF, as this here is to this here, okay, so is the angle BGC, BGC, okay, to the angle EHF, EHF. And the angle BAC, BAC, okay, is to the angle EDF, EDF. Okay, so how are we going to draw these little puppies? Well, I made this angle BGC 60 degrees here. I made this 60 degrees, and BAC is 30 degrees. Okay, and then I went on to make angle EHF. See EHF right there? It's 30 degrees, and I made EDF 15 degrees. So this is 30, this is 30, and this is 30. This is 60, this is 60, and this is 60. And you see this line from G to A, just ignore that. That really is not supposed to exist at all, but I made a blunder, so there you go. Okay. For let any number of consecutive circumferences CK, KL be made equal to the circumference of BC. Well, CK here and KL here. This is 60 degrees, this is 60 degrees, and so is this. Okay. And any number of consecutive circumferences FM and MN, FM and MN, this is 30 degrees, this is 30 degrees, and this is 30 degrees here. So any number of consecutive circumferences FM and MN be made equal to the circumference of EF, which we've done. And let GK, GL, well, where's GK? Well, GK, okay, GK, GL, HM and HN. HM, HN be drawn. Okay? Then, since the circumferences BK, CK, and KL are all equal to one another, and angles angle BGC, okay, well, here's B, and here's G, and here's C, and CGK, that's this one here, and KGL, and that's KGL here, they're all equal to one another. These 3 angles here are equal to one another. And this is by Euclid Book 3, proposition number 27. Therefore, whatever multiple of circumference BL is to BC, the multiple also is the angle BGL of the angle BGC. So, BL, so whatever multiple of BL is to BC, okay, that multiple is also the angle BGL of BGC. BGL, BGL, and BGC. BGC. Got it. Okay. For the same reason also, whatever multiple of circumference NE is to EF, NE, well, where's NE? NE to EF, okay. That multiple also is the angle NHE to the angle EHF. Well, what's NHE? NHE and EHF. So as this is to this, as this plus this plus this is all of this, so this plus this plus this is all of this. Okay. If then the circumference BL is equal to the circumference EN, BL is equal to the circumference EN, the angle BGL is also equal to EHN. Well, if this was equal to this, so this BGL would be equal to EHN. Okay? By Euclid Book 3, proposition number 27. If BL is larger than EN, okay, if BL is larger than EN, then of course angle BGL is going to be bigger than EHN. And so on and so forth. There being then four magnitudes, two circumferences BC and EF. Well, here's BC and here is EF. And two angles BGC, and EHF, there have been taken of the circumference BC, and the angle BGC equal multiples, namely the circumference of BL and the angle BGL. BL and BGL. Okay? And of the circumference EF and the angle EHF, here's EF, right here, EHF, okay? Equal multiples, namely the circumference EN to the angle EHN. EHN, EN. Okay. And it has been proved that if the circumference BL is in excess of the circumference EN, the angle BGL is also in excess of the angle EHN, if equal, equal, if less, less, so on and so forth. Therefore, as the circumference BC is to EF, as BC is to EF, okay, we have BC here, EF here, so is the angle BGC to the angle EHF. BGC, EHF. Okay? This is by Euclid Book 5, definition number 5. But as the angle BGC is to the angle EHF, BGC, EHF, so is the angle BAC to the angle EDF, for they are doubles respectively. BAC, okay, and EDF. Up here. See? There's a D right there. Okay. Therefore also, as the circumference BC is to the circumference EF, as BC is to EF, so as the angle BGC, BGC, to the angle EHF, EHF, and the angle BAC, BAC, is the angle EDF, EDF. Alright, now you say, why in the heck would you ever use something like this? Okay. Well, I'll explain that to you. I know it's kind of gone around and around and around and around in circles, but anyway, let's say that G here is the sun, okay? And let's say that H here is also the sun, okay? Now we're going to say that the sun never moves. That's why it's the center of both this circle and this circle. Now, we have another star here, and it's A. Now this star A doesn't move either. Okay, A is stationary, so is D. But the Earth moves. Now, let's say you wanted to come up with a ratio between the time that the Earth moves between the month of August and the month of September. Well, what you can do is you can measure the distance, like say BC here. BC would be the distance that the Earth moved in a month, say August, and EF would be the distance that the Earth moved in September. And now you can come up with a ratio for when the Earth moved between August and September. And you can do this with a sundial. Now I don't own a sundial, and I'm not going to go stand there buying a sundial to illustrate all this stuff to you, but if you want to do the research, you want to do stuff with a sundial, you go right ahead. But the point is that you can make a ratio between how far the Earth travels in August and how far the Earth travels in September by using a proof like this. You can tell how far you've traveled in the cosmos by using stuff like this. And that's why we have stuff like this. The Egyptians knew all this kind of stuff. Now, so do you. Alright. Thank you folks for tuning in to Euclid Book 6. This is the last of it, thank heavens. And I can actually show you from the proof. We have as 30 is to 15. No, I'm sorry. As 60 is to 30, so as 30 is to 15. That's basically what this proof said. Hopefully you enjoyed all these proofs. When we start Book 7, we're going to be talking about prime numbers. We're going to be drawing magnitudes, and that's all. We're not going to draw any funky shapes between Books 7 through 9. Thank heavens, I don't think I can take any more of this. So anyway, you guys have a wonderful evening, and we'll start Book 7 probably in the next few days. Stay tuned.